Cool.
Oh, Google's trying to annoy me. You're good, Troy.
All right,
do whatever you want now.
So we're going to talk about GopherJS because we all hate JavaScript. Although so GopherJS lets you write Go and run it in the browser. And I do have to be honest, I was interested in this, but I started out very cynical about it. And when one of my coworkers found out this was what I was speaking about, this is what he said: "I cast you out, unclean spirit." And I am still pretty cynical about it. But after I've thought about it a little bit, I don't think it's necessarily as terrible as I originally thought. So before we dive into GopherJS, though, I think we're going to talk about JavaScript a little bit. And I want you guys to imagine that the entire population of the planet Earth gets transported to some brand new planet. But the only thing that's there is us and the planet. So we don't have any of our tools or anything like that. And it's beautiful, but I think humanity would die pretty quick. I don't think there's any way we could take the knowledge of our modern lives and try and figure out how our ancestors created things like these factories so we could build cars and stuff. And those factories come with pollution, but we get a lot of cool things out of all these tools. So I think when you're a new JavaScript developer, to be a good web app developer, I feel like you kind of have to go back through history and pretend that start with the web is brand new and I'm learning how to work on the web. And then you go through all of the tools that got built over the last 30 years. And that's where you end up with React. And you understand how we got to React and where we're going from here. So we're going to kind of talk about the history of the web a little bit. Here's a screenshot of the first website. It's beautiful and functional. It's got links to other websites.
Did you visit that, Troy?
I found this on the net. Using a website called Google.
On that website?
Yeah, it's really good. And you could see why we refer to websites as documents, because this is just a document. That's how it started. Just a way to share documents with other nerds. And it's great. It's functional, but it's not very pretty to look at. Whereas now we've added all of these tools, and now we have really beautiful web apps like this, and you can imagine all of the amazing animations that happen when you click on parts of this web app and things popping and bouncing, and it's just so delightful. This also has some pollution. So on the left, you'll see a list of languages that compile the JavaScript, and there's like 30 of them. This is from last year, this other screenshot. There were 1 million packages on NPM, which are all the JavaScript libraries that the JavaScript developers need. I think this metric is even more impressive. It's almost 11 billion downloads in 1 week. And I think there's something like 11 million JavaScript developers. So they were each downloading packages from NPM 1,000 per week. That's crazy. So pop quiz. The operating system in which a web app is installed is called what? Or is what? What is the operating system?
It's not a browser. I don't know.
It is a browser. That's what I was looking for.
Oh, it is?
The browser.
It is a browser? Oh, I'm so proud of myself.
So that code is running in the browser, and like the browser might change a little bit, or it might be Safari or Chrome. And it might be Safari on Mac or Chrome on Windows, but the Windows part of it isn't as important as the Chrome part of it. So that's the operating system. And the only programming language the operating system knows, at least historically, has been JavaScript. So we're going to talk about JavaScript a little bit. So in the early 90s, we had websites that looked like that one I showed you. They were very boring. They were static, but they were gaining traction and popularity. In the mid 90s, Netscape had the Netscape Navigator browser, and they wanted to push the web forward and add some interactivity. So they partnered with Sun, who was working on the Java programming language. and created JavaScript. And the idea there was that Netscape would create JavaScript and it would be very lightweight and easy to use and do simple things, whereas Sun would create Java and it would be used for what they called quote unquote programming in the large. So for bigger applications, you would use Java. And that's why it's Java and JavaScript. And then another interesting thing about this is that they wanted JavaScript to be easy to use because people that were creating websites weren't developers. They were academics or whoever. And so they needed a programming language that would let them script some things, but do it easily. So JavaScript became popular very quickly. So other browsers had to implement the JavaScript engine in their browsers, basically to be able to compete. So Microsoft created JScript, I think it was called, and I mean, it was more or less the same with some minor differences, but that way a website could run in Netscape or in Internet Explorer. But there were these competing JavaScript engines were becoming a problem. So in November of 1996, they created ECMAScript, which is the standardization of JavaScript. In 1997, we finally got the Java applets for quote unquote programming in the large. But to run a Java applet, you have to have Java installed on your computer and you have to install a Java plugin in your browser. So it's not as easy as going to a website and running it. You get prompted to download something. In March of 1999, AJAX was introduced, which is asynchronous requests to pull in data. I think that's pretty interesting that it came that late. But at this point, now a website, once it's loaded, you could load more data from a server and put that into the website. In the early 2000s, ECMAScript 3.1 is being worked on and ECMAScript 4 is being worked on. So from 96 to the early 2000s, JavaScript is born and it's standardized and they're making progress until early 2000s, and they're working on 3.1 and version 4, and they just cannot agree on anything. Version 4 introduced a lot of new stuff that Microsoft was like, no, we don't want that new stuff. They couldn't get consensus. So by January 2006, jQuery is born. And if you've ever been a web developer, you almost definitely have used jQuery. It makes a lot of the problems of JavaScript from before 2006 a lot easier to deal with. Yeah. So in 2007, yeah, go ahead, Mariah.
What? Never mind. I was going to ask a really dumb, sarcastic question.
Ask it. I love those dumb, sarcastic questions.
I just wanted to know, everybody talks about how revolutionary jQuery was. And like, for my limited JavaScript knowledge, it didn't seem to be that way. I want an example. Can you give an example of how amazing it is?
Well, I have some very small example code here in a minute. But it does just simplify a ton of the common things that people were doing in the mid 2000s.
Okay.
And it's all about taking this JavaScript language that was created for simple scripting and making it usable for quote unquote programming in the large. And that's what ECMAScript 4, while they were working on that and trying to make JavaScript usable, they couldn't agree on anything because it was such big changes, because they were using JavaScript for things it was never meant for. And so we had the Java applets that was supposed to solve that problem. In 2007, Microsoft created Silverlight, which is their answer to the Java applets. So it took them 10 years. And Adobe releases Flash with ActionScript, which is their version of, it's kind of like TypeScript. It was JavaScript, but better. But both of those things were meant for programming in the large, building real applications. But again, they all required installing plugins. No one really liked that. So by 2008, so 8 years later, they finally decided to give up on ECMAScript 4. So basically from the late 90s to 2008, JavaScript hasn't changed at all. And instead, people have been adding either plugins or libraries to try and make JavaScript better, usable for the web. By 2009, ECMAScript 3.1 is accepted. So from version 3 to 3.1 took at least 9 years. And they decided to rename it to ECMAScript 5 because it just took too long. And in 2009, AngularJS is born and CoffeeScript is born. And CoffeeScript is a JavaScript alternative that transpiles to JavaScript. 2013, so 3 years after Angular, React is born. And then finally in 2015, a lot of the original ECMAScript 4 changes that were meant to help make JavaScript better for bigger applications were finally accepted and called ECMAScript. Well, it was called ECMAScript 6, and then I think it was renamed to ECMAScript 2015. And then a new thing called WebAssembly was announced, which we'll talk about a little bit. 2017, ECMAScript 2017 introduces async and await, which is another big syntactic change. 2019, WebAssembly 1.0 is released. And by May of 2020, so just barely, 91.66% of browsers support WebAssembly, which is pretty neat. So looking into the future, I think we'll see WebAssembly languishing for the next few years because everyone has spent the last 30 years adding tooling to make JavaScript work for them. And then by 2034, we're going to see WebAssembly finally dominates the web. Those are my predictions. You guys can call me in 2034.
You think it'll take that long for WebAssembly to dominate the web?
Yeah, I think so. And I mean, JavaScript's never going away, but we'll see. I just think it's interesting, like how many different tools were being worked on, either plugins or libraries, to try and make JavaScript work for building real web applications. And it was a huge need, but these big companies that were involved in this brand new industry, none of them wanted to give up control, and none of them could agree on anything. And a lot of people blame Microsoft for the ECMAScript 4 languishing, but I don't know that they're completely wrong. Like I feel one of my complaints about JavaScript is that I feel like I don't use it every day. So every time I go to a JavaScript meetup or something, I feel like it's a brand new language and I don't really know what's going on. Like async and await, or they have this word called yield, which just makes no sense to me. Anyway, so, but it's interesting. There was a lot of work going on to try and make this better. And I feel like we're finally kind of in a good place with JavaScript, which is interesting. But so this entire saga, all these tools were built out of the need to do just one thing. Does anyone have a guess for what that is? Also, we have a newcomer. Who hello. I can't see your name on my screen. Just a sec. Hello, Jason.
Hi.
Do you have much background in JavaScript or front-end development, Jason?
I spent 4 or 5 years doing it. Sure.
Cool. Okay, cool. Anyways, does anyone have a guess for the answer to this question?
The entire... No, I don't.
Okay, I'll just give it to you. The answer is DOM manipulation.
Oh, that
Basically,
makes sense.
I'll show you a demo. Basically, they wanted this to be able to happen. Since the original web was just those documents, like, uh-oh, that's not going to work. You know, since they originally looked like this, they want to be able to change the document after it gets loaded into your browser. So the document it has some objects in it, different elements, and if you could tweak some of the properties of those elements or the content of those elements, then you could build an interactive web page. So for example, in this one, we're tweaking the position of this square, of this div. So it seems like a lot of technology being built just to move boxes around on a web page. And really, it's called DOM manipulation because you can think of it as like you're laying out a document or a page and all the little pieces that are there individually, and you have to grab one individually, change that thing, change whatever property about it, and put it back. So you're like really manipulating it with a fine-tooth comb. So some examples of some code over the years. In order to do DOM manipulation, you need to be able to select an element, And to create an element, those are some things you might need to do. After you select it or create it, you'll need to be able to change some properties about it. And then the browser would know how to represent those things. So in vanilla JavaScript back in early 2000s, it might look like this: document.getElement by ID. And then you give it the ID, document.createElement. And then that would return the element. Then you could change things on it and then add it into the DOM. JQuery looks like this, Mariah, so you can see how much better it is. It really is better because now we're using the exact same function to either create a new element or select an existing element. And you can use
So it
CSS
just makes
selectors
it
here.
easier?
Oh yeah, way easier.
Okay.
But it's important to understand that under the hood, it's doing the exact same thing. Like, we're never going to get away from this with any of these tools I'm showing. None of this goes away. It's just being abstracted. And it's a lot easier to use if you're doing a lot of DOM manipulation. AngularJS is pretty revolutionary in 2009 because it removes the idea of directly manipulating the DOM at all. And now you write HTML and you embed in the HTML some tags, and then the AngularJS library will replace those tags with the correct data, and it will do the DOM manipulation for you. Really cool. React.js also kind of flips the script, and now instead of adding tags into the HTML, you're adding your HTML into JavaScript, but it's a similar idea. But again, we never get away from this DOM manipulation. Like, that's what's happening under the hood. So let's talk about transpiling. This is the process of using a compiler to convert from one programming language into another. There's at least 24 languages on a list I found that can be compiled into JavaScript. And I just have to ask, like, why are people doing this to themselves? It seems insane to be writing a compiler to convert from one language to JavaScript. I feel like debugging bugs is hard enough in the language it was originally written in, and now I have to do it in 2 languages. And that's what we're talking about today, is GopherJS. That's what it does. And I do feel like I want to mention WebAssembly because I think it's really interesting. So WebAssembly is an open standard for running binary programs in browsers with near native performance. So now, instead of me as a web server sending JavaScript to the browser to run, I can send a binary program and it will run that. It will allow for other languages on the web instead of just JavaScript. So we can bypass JavaScript entirely. But on their own website, one of the frequently asked questions is it a replacement for JavaScript? And they say, no, exclamation point. It's supposed to be a complement to, not a replacement of JavaScript. They say, while over time, it will allow many languages to be compiled to the web, JavaScript has an incredible amount of momentum and will remain the single privileged dynamic language of the web. So certainly not going to replace it anytime soon, but I do think it is an interesting part of history that we're in where we might see this gain a lot of traction. Depends what the tooling is going to look like over the next few years. There's a link there that you can see why WebAssembly was created. And then I think these demos are pretty impressive. I'm not going to show them just right now, but they show a game running in Unity engine that runs right in your browser and doesn't require you to install any plugins or anything. So I have a few demos of showing GopherJS in action that we can go through. And then if you guys have any questions or comments, just shout them out at any time. I ruined the... Okay, so we're going to look at this very simple program. It's just going to do some DOM manipulation to change our website. And GopherJS is really cool. It comes with a little command line tool that more or less replaces the Go CLI tool. So there's GopherJS build, there's GopherJS serve, and it will take your, I already have it running somewhere. Oh dear. Sorry, just a sec. Well, that's okay. I will use a different port. Okay, so it will, in here, I just have main.go, but GopherJS will compile this in real time as I make changes and then serve it to my browser. And you can see it, even though there's no index file, it just wrote hello world to the screen, which is pretty cool. And if you want to see why someone would use this, I'll do GopherJS build. And you see, this program is 7 lines long in Go. In JavaScript, the same program to change the screen to say hello world is like 2,200 lines long. So 2,400 lines long. So obviously, we're Go developers. We love Go. That's how much easier it is in Go than JavaScript. Obviously, I'm being a bit facetious because really, this is 1 line of code in JavaScript. But for whatever reason, when you compile with GopherJS, it has to include the whole Go runtime. So we get a program that's 2,200 lines long just to change this hello world. But by including all of that, you do get some pretty cool stuff. So for example, GopherJS supports pretty much anything you can do in Go, including Go routines. So we'll spin up another Go routine here. And in this Go routine, we're going to say goodbye. And we're going to do it after 5 minutes or 5 seconds. So our page will load. We'll start this Go routine. Then we'll change the screen to say hello world. And then after 5 seconds, we'll say goodbye world. Hello world. Wait 5 seconds. I think it's been 5 seconds.
It said something.
Yeah, it's giving me some warnings over here. Well, perfect. This will give us a chance to show off the debugger. So,
I mean, it did exactly what you wanted it to, right? Because it said change it to hello world.
I forgot to change my text. Thank you. Here we go. Goodbye world. Yeah, I said hello world and I said hello world again. Nevertheless, it is pretty handy or pretty impressive that we can debug our Go program right here in the browser, which I think is a must-have if you're going to use a tool like this. Because like I said, it's already hard enough to debug a bug in one programming language. I don't want to have to dig through the generated code to see what's going on. But fortunately, the tooling is pretty good. It sets up the source mapping so that you can look at your original source and see what's going on, and you can skip through this. And I think it's pretty impressive. So that's cool. That's a simple example. Let's look at my next. Oh, there we go.
I have a question.
Yeah.
What
Shoot.
version of Go are you using?
Okay, that is a good question.
Because
GopherJS?
I swear it broke when I tried to do it with modules.
Yeah, you have to switch. You have to use Go 112 with GopherJS, or else it
And
won't
no
like you.
modules.
Yeah, I haven't tried with modules, but yeah.
Okay.
I mean, modules looked a lot different at Go 112 than it does now, too. So,
Yes, they do.
Yeah.
I agree.
so it is getting GopherJS up and running was a little bit of work. It wasn't as super easy. I had to switch the Go version, my Go version, and there's some other hiccups I ran into, but
I have another question, if I can
Yeah.
bug you again. So
Yeah.
I know that you were commenting a little facetiously about how the Go file that has 5 lines in it generates into a 2,500 line JS file.
Yeah.
And the JavaScript file does not need to be that. Like, you could handwrite a simpler JavaScript file that does the same thing, right?
Yeah.
Do you know why it's so long? Is it maybe not leveraging some of the cool JavaScript stuff like JQuery or
It's
other cool
because
things?
it's including the whole Go runtime. So all of the standard libraries being included in that 2,500 file or line file.
Okay.
There, you could use like, I think you could use like tiny Go. It's a subset of Go, and you could end up with a smaller file and fewer features if you really cared about that.
Well, you're generating it, so I don't know why you'd care. I was just wondering if you knew why.
But yeah, you might care if you are actually wanting to put this on a website because it will take a little longer to load. But yeah. So this next example is just to show that we can tie into some events. So there's a index file now. It has a button, and we're going to use DOM manipulation to add to this button. So we use document.getElementById, just like we do in JavaScript, but now we have a statically typed element, and that statically typed element has a function called addEventListener, which takes a callback function. And when this button gets clicked, we're going to create a new element. And when we create that element, we typecast it to be a statically typed image element, which is nice because then it shows us the properties that an image has, such as source. And this is stuff that you wouldn't get if you were using just JavaScript, which is kind of nice. So then you can set the source, set the height, and then we're going to append that image to a container element. So when I click this, it's going to execute that event listener, and we pull in an image from this person does not exist, which I kind of don't believe. I think these are real people. But
that is my favorite website, Troy.
yeah, it's pretty good.
I've
So
used
that's
it
cool.
for talks.
Yeah, it's great. That's cool, but we kind of already talked about this a little bit, but let's talk about what happens when there are issues, since there's always going to be issues. So if we have this is the same program, but now there's going to be some issues. So if I refresh the page, our button doesn't do anything. And if we check the console, we see main.go, line 17, X declared but not used, which is a compiler error. So our program didn't even compile, but our browser still showed us the error and showed us the correct line numbers, which is pretty cool. So line 17, var X, not used. Oh, okay, so I just removed that. I'll refresh. And now it says, hey, which is what it says at the top of my program. When I click it, though, I get a panic that says, oops. And this one's not quite as easy to parse through. If I click on this link, it's going to take me into the depths of the generated code. But it does show me in here main.go line 21, and then I can look at my original source, which is cool. Now I can remove my panic. Oops, I didn't need to do that. And now our program works beautifully again.
So is that from, you mentioned a debugger. So you're saying that the console and your dev tools in the browser are going to be your best tools for debugging these things?
Yeah. Yeah. So you still get, like, as a front-end developer, you would still get to use the same tools in Chrome that you know and love, which is nice. But everything we've looked at now is basically the equivalent of vanilla JavaScript. And we know in 2020 that we're never going to write any real web apps or programming in the large with vanilla JavaScript. But it's important to know that we can do those things, because that is what all of our tooling, all of the JavaScript tooling is built on, that vanilla JavaScript. So if we look, but Gopher.js has an answer for this as well. and it's called, at least one of them is called Vecti. There are actually React bindings for GopherJS, so you can use React in Go in a statically typed environment, which, again, part of me is wondering, why would you ever do that to yourself?
Because I don't want to type JavaScript.
Yeah.
That's the reason.
That is the reason. So Vecti is it's almost exactly like React. And I think it's important to realize that while we joke about there being new JavaScript frameworks like every 2 weeks, React, I think, really did change the game in a lot of ways, in that it might not be around forever, but a lot of the concepts that it has introduced will stick around. I mean, Angular 2 looks a lot like React. Vue, I think, looks a lot like React. And the whole idea of React is you build components. Each component knows how to render itself, and then you compose the components into a web page. So with Vecti, our website's now going to look like this. It's going to have a page. It's going to have a button. It's going to have a component called portraits. And then inside of portraits, we're going to have a bunch of images. And the button component and the portraits component need to be tied together in that when I click the button, that changes the state of the portraits component. It needs to add a new image. So in Vecti, it ends up being laid out similar to a React app. You define each component and then you compose them together. And each component has to implement a render function that returns a Vecti component or HTML, which is just the HTML that needs to get generated for that component to render. So we render body, we start with this page view. A page view has in that body, it has a button and a portrait container. The button has an on-click handler, and when that gets clicked, we're going to call the add function of the portrait container. Here is the portraits container. It just has an array of URLs, which are the portraits we want to show. And then it has an add function, and every time add gets called, we're going to append a new URL to our list of URLs. And then every time render gets called, we look at the list of URLs and we render a portrait image element for each of those URLs. And then finally, the button has a on-click handler. It's just a function. And when that button is clicked, we call that on-click handler. So we'll see this in action. It's not that fancy because it just does exactly what our other program did. It just took more code, so obviously it's better. So I think Vecti is pretty cool. And if you don't believe me, if you don't believe it could be used for a real website, this goplay.space is a improved version of the Go playground. And this whole website is built using Vecti, which is pretty neat. It works well. I've dug around a lot in the source code of this project to try and build something similar. I was trying to get that up and running for you to show off, but I couldn't quite get it hosted and working.
You tried to build this whole thing?
Well, I was using part of this code to.
You're really dedicated, Troy.
Yeah. But overall, my impression of GopherJS is that it's okay. I don't know that if I had a front-end project, I don't know if it'd be my go-to tool. But I think it's probably has a place in the world, and we'll see where it goes from here. I was able to also get this exact program compiling to WebAssembly, which bypasses the need to compile to JavaScript at all, which also wasn't completely seamless, but it's going to get better and better, and we'll have better tooling. And I think it'll be interesting to see where the web goes in the next 5 to 10 years.
I think you have to use TinyGo for WebAssembly to compile Go to WebAssembly, don't you?
I don't think you have to, but if you were being serious about
no.
It's supported in the latest versions, I believe, is a native like target.
Yeah.
Okay.
Yeah, it's not totally required, but if you were serious about hosting a website, you'd want to like trim it down as much as possible. So yeah. Anyways, GopherJS. That's my review. B+.
Out of curiosity, how big was the WebAssembly?
Here, let's see if I can rebuild it right now, and then we can dig into that. I have it should be easy because it copied the command right here. So the WASM file, which is the binary file, that replaces the compiled JavaScript. Let's see, how do you make this? Yeah, there we go. Was that 2.7 megabytes?
That's not bad.
I don't know. I'm not a web developer, so I don't really care about these things.
You're not?
Yeah. So just the compiled JavaScript for this program is 1.2. So in this case, if all you cared about was the bytes that you had to transfer, you would prefer to just transpile the JavaScript, which I think is kind of funny.
But isn't the size for the same reason that the JavaScript is so long? It's because it's taking the entire standard library and...
Yeah, I wonder if I got to working with TinyGo, I wonder how big that would end up being. I don't know. I didn't go down that avenue
TinyGo is
at
a
all.
fun thing to mess with, but just know, from a personal experience, it doesn't work on Windows. It
Okay.
kind of works on Mac, and it works really well on Linux.
Kind of works, cool.
That's awesome, Troy.
Yeah. Anyway, any other comments or questions? We get our DoorDash delivered to us? Mine hasn't come yet, Mariah.
I'm sorry, Troy. You forgot your address, so I just had it delivered to my house.
Oh, okay. Cool. Well, Mariah.
Okay, I'm going to stop the recording.
Close it out.